Welcome to Bits and Bytes Live, the short discussions that we have here at VMware, looking to put a focus on subjects of the day through the lens of the communication service provider. My name's Nigel Stephenson. I'm Director of Market Development for Europe, Middle East and Africa here at VMware within the Service Provider and Edge Business Unit. And today we're going to actually start the second of two the second conversation of a series that we're doing on the evolution of the radio access network, the evolution of the RAN. And to do that, I'm joined by Sachin Katti, who is co-chair of the technical steering group at OpenRAN Alliance and advisor for VMware, and also Lorcan Burke, who is director for RAN technologies within our telco vertical. So welcome, gentlemen. Thank you for joining us. And I'm going to sort of steer the conversation, but you guys are the experts. So I'm looking forward to getting your views. We're going to talk about three different areas, and I should say for folks listening, we're going to look at it from a point of view of people who are maybe getting interested in this area, trying to understand some of the buzzwords and the technologies and the organizations involved. So we're going to try and explain some of that and try and position things that you might be hearing as you're looking into this into this part of the market. So we'll cover off three different areas. I think first of all, I want to talk about some of the organizations that are driving the evolution. Then I'd like to have a bit of a discussion about the impact on the people, because we often talk about the technology, but it'd be good to talk about what this means for individuals working in this space. And then we will come back to looking at some of the key components and where we are on the timeline of delivering on the vision. So to kick that off, maybe Sachin, if I could go to you, there are a few organizations that I keep seeing come up. 3GPP is one, OpenRAN Alliance, which obviously you're very connected with yourself, is another. Can you tell us a little bit about those organizations, where they fit in the industry, you know, what they're trying to achieve and how they work together towards the evolution of the RAN?
Sure. Thanks, Nigel, for having me here. Really great to talk to everyone. So all three organizations are playing important and critical roles, and they're all playing complementary roles. So just a little bit of history. So 3GPP is the granddaddy of all, right? So it's been around for a really long time. And OpenRAN is, in some sense, the newest kid on the block. It has only been around 2 or 3 years now. OpenRAN, when we started it 3 years back, the intent really was to fill a huge gap in the industry, which was that to give operators a forum where they could come and present in a unified manner what they want to see with the network architecture. How do these customers of ours want the network to evolve into a more open, more disaggregated, more programmable network architecture in the future? And so that's really what OpenRAN is focused on, really on the network infrastructure side. How should we think about programmability? How should we think about disaggregation? 3GPP is more focused on the air interface. It is, of course, doing a lot of network infrastructure work, but also the air interface, which is how should a phone or a device talk to the infrastructure? And OpenRAN does not play any role in that, so we really build on the work 3GPP does there. It's very super critical work, obviously, because we all are so used to now using our mobile devices for everything. So in some sense, those are the two complementary roles that OpenRAN and 3GPP play. And I really look at TIP as, an organization that figures out how to prototype these things and get them to reality. So OpenRAN and 3GPP focus on the architecture, focus on the interfaces. How should we kind of modularize and disaggregate the whole system? But we have to show that this actually works in practice, prototype them, bring small vendors along, and that's really where TIP plays a critical role.
Thanks. And Lorcan, I think you've been involved quite a lot with TIP yourself, haven't you, Lorcan? So you've probably got perspective there.
Yeah, last 3 or 4 years, working on a couple of aspects of it. One being the ecosystem acceleration programs, so the TEAC activities, where we've been working quite a bit with operators and earlier stage businesses around trying to plug specific gaps, whether it's millimeter wave or front haul activities, and then actually trying to assemble things. So we've got project groups and solution groups. The project groups have been focused on things like in OpenRAN, how do we aggregate requirements from all those operators Sachin was talking about, and bring the vendor community together to that. So at least if somebody says, I need 50,000 roughly size and shape radios that go in street form factor, we can work on that. We can bring vendors along, help fund some programs. And then solution groups where we plug those together and put them in the real world. So we've done open source mobile data offload to Wi-Fi with open Wi-Fi components, with open packet core bits, all orchestrated and managed. And we've done some work on the likes of connected city infrastructures. How do you really build and densify networks in city and urban and rural environments? So a lot of it, yeah, the kind of maybe the kind of more prototypey delivery type stuff, I think Sachin, is probably the complementary area, right? So we'll smash it together and figure out the bits that don't work, and then feed that back into ORAN and 3GPP to get next releases of standards and clarifications done. So quite interesting, very complementary roles, I think. Yeah.
I'm going to say it sounds quite cooperative in a sense, because I mean, is the membership different across these organisations? I mean, how would you characterise the membership across the three different groups? Is it different, or is it the same people?
I think there's really large overlap, as you'd imagine, right? So in this community, ORAN now pretty much has every vendor, every operator member as a member now. 3GPP, of course, has been in that way for a long time. I'd say TIP has done a great job in enabling and investing and grooming new startups that are trying to enter the space, and really giving them a forum to come showcase their technology. So, but I think there's large overlap among all three organizations.
Yeah, exactly.
All right. So good. Well, thank you for that, because that gives some clarity. Because you see, as I say, you see these names coming up, and if you're new to it, it's not always obvious what they're doing. I think there's some differentiation there, but there's a lot of collaboration, which is good to see. So, as I say, I wanted to talk as well about the people involved. So, if we're essentially what we seem to be doing here is, if you're a traditional sort of if you're coming from a traditional RAN background, if we call it traditional, then what you're seeing is a sort of a cloud world coming towards you as the RAN becomes more cloudified, more cloud first, if you like, and adopting principles that are born in the cloud. If you're a cloud person, you might be, in an organization where you're looking across to some of your colleagues or whatever in the RAN space and seeing the RAN come towards you. If we start, I suppose, let's focus on the RAN team. If you're in a RAN team at the moment, and you're sort of looking ahead as to how this technology wave is going to affect your organization and your role, how do you see that playing out? What's going to be different in the future in a disaggregated RAN for the people versus how they might operate in a more traditional sense?
Yeah.
So, Sachin, yeah, if you want to have a go at that one first.
Sure. I think so. The RAN historically has been a vertically integrated kind of monolithic appliance, right? So that's how you typically deployed it. With OpenRAN, you're kind of disaggregating it at least at three levels. So the radio hardware being disaggregated from the compute infrastructure, and the compute infrastructure itself running a cloud on top of which you're running the RAN software as basically a cloud-native application on top. So we've gone from a world which was basically an appliance to three different components: radio hardware that sits on radio towers. There is the compute infrastructure, including the cloud layer, and then there is a RAN applications themselves, which is where you do the tuning of the RAN service and so on. So I think that's a pretty big cultural shift for a lot of these teams. So they're going to go from having to deal with one vendor, if you will, to having three sets of vendors in each of these different components. So they play more of a role of a gatekeeper, someone who is doing the triage whenever issues come up to figure out who should I call, how do I make sure that we deliver the best customer experience as this gets deployed. The other big obvious cultural shift is that we are introducing new technologies like Kubernetes to the RAN domain, right, which has never been typically deployed. So that's a pretty big shift. That's I think an opportunity for a lot of RAN engineers, because this is obviously going to be the way applications are going to get deployed anywhere in the telco industry now going forward. So having an opportunity to get experience with the cloud, also bring their own perspective on critical performance requirements that the cloud may need to deliver, which are applicable elsewhere. I think amazing opportunities also, not just a challenge to be solved, but there are also amazing opportunities for RAN engineers to grow in their careers.
And this is and if I understand correctly, and Lorcan, I think this is, you were talking about this the other day with me. Because of the way the systems and services will be built, the move towards a disaggregated RAN actually provides more control potentially for the RAN team, but that in the sense of development of services and applications. Is that right? Is that how you see it?
Yeah, I think the interfaces that Sachin's been working on the last couple of years, and the product developments in things like this, the likes of the RIC, or the RAN intelligent controller, opening up things that have previously been very closed in terms of how do you allocate resource in the radio network. That allows us some interfaces to bring together data from other parts of the network. So there's always been teams in RAN operations who look after a lot of data. They have a lot of KPIs, crunching a lot of information. Having these types of interfaces allows us to use that next, more current sets of skills and development techniques to join that data together and drive real improvements in radio performance. It also means we can start driving some of the feature requirements, or at least prototyping them and helping drive the other vendors to a level of performance or agility that's they're constrained by their need to deliver quality software a lot. That often constrains their ability to innovate. Whereas we can show in those RAN teams now, we can at least get to a first level of things working, and then get it into production, and then it can be productized afterwards.
So there's a kind of the plus side is you're controlling more of your own destiny. Against that, there's the complexity and the skills to be acquired to build those sort of development environments and to be able to take advantage of that new capability. So it is going to
it will change
environment.
It's an interesting change in skills, because I think it'll start attracting a new set of talent into the domain as well, right? I mean, traditionally, it was hard to get people with software skills into the radio teams and into these kind of development environments. I think the openness of interfaces and the types of skills needed are very attractive in multiple industries. So it will allow us to bring new talent and skills into telco and allow us to innovate, right? So I think that's quite critical, and it's I think people underestimate the need, or the need for those types of skills, because that allows us to be agile and customer responsive. So really critical stuff.
Thank you. So we've got a question coming in. I'll stay with you, Lorcan, if I may. Abdul's asked a question. He's a strategist and advises clients. He's asking for our opinion, or your opinion specifically, on legacy. He's saying a lot of operators have a desire to move towards things like OpenRAN, or OpenRAN specifically, but equally they need to keep things like 2G, and 2G, I guess, amongst the previous Gs is probably a predominant one. Your thoughts on that sort of dual world going forward? Certainly. I mean, I've been around for a few of these generations. 2Gs will probably outlast me in this industry, right? So I think we have electricity meters connected with 2G all over a lot of major markets. We've trucks that are running around with 2G modems in them, still connected for fax replacement. That it isn't going away, let alone emerging market requirements. So the cost-effective nature of the devices and modems in that space, it won't go away short term. The good thing is there are vendors like Parallel Wireless who do a great job with 2G, 3G, 4G, 5G coming along quite nicely. Mavenir acquired IP Access, who had a fairly strong 2G stack, which was virtualized. So I think we'll see quite a good convergence of kind of cloud, maybe not cloud native, but cloud rewritten, right? And we do a lot of that in our world, right? We bring apps from legacy to modern apps frameworks. I think that will continue to happen.
And 2G will probably outlive 3G in a lot of markets, and you will end up with 2G, 4G, 5G infrastructure, and maybe 2G, 5G, who knows. And I think like for the likes of Detacon working through some of these things in the Nordics, those infrastructures will stay for quite a while. So yeah, I think we'll see a lot more action in the 2G space, particularly in emerging markets.
If I just to check that, are you saying that for as we look forward, 2G could exist in a kind of ships in the night way, so it could just coexist, but potentially there are also ways of bringing the two worlds together in a more cloud-like fashion, albeit that it would probably be reformatting 2G rather than changing it per se?
Yeah, I think that the legacy, if you like, the BSC, which was this base station controller, which existed in 2G, the software for that has been virtualized. It will be containerized, and likely the containerization plus some of the interfaces will drive that back into the use of maybe a RIC type capability across the two. Sachin, I don't know, is that something you'd foresee? Maybe.
Yeah, so I think maybe that's a good segue. So we will definitely have 4G, 5G for sure in a lot of deployments, right? That are going to have kind of maybe potentially legacy infrastructure and new open RAN infrastructure, and potentially as far back as 2G for certain connectivity applications, like Lorcan said. So I think we totally see 5G, for example, being deployed using an open architecture for new spectrum. So when 3.5 gigahertz shows up with mid-band massive MIMO kind of deployments, that definitely is where 5G will get deployed, and there's an opportunity to deploy new open RAN architectures, right? Yeah. And there will be components like the RIC that will connect to both 4G and 5G infrastructure, and allow you to optimize, handoff, mobility, load balancing across the 2-axis technologies, maybe even bond them in interesting ways to deliver better capacity or network slicing capabilities on top. So there are means of adding programmability to existing legacy infrastructure, and definitely with new open 5G infrastructure, such that the programmability enables you to handle the interoperability between these two kinds of systems and get the best out of them. So I think that's where the RIC is going to play a critical role. You might have seen some of the announcements literally 24 hours ago from Vodafone where VMware and a bunch of partners have been working with Vodafone on. And this is a world first where the RIC was demonstrated, where it showed the ability to deliver multi-user MIMO on OpenRAN technologies. And this is important because one of the knocks or criticisms that OpenRAN has had to face over the last year has, will this be able to scale? Will this be able to deliver the great capacity that everyone needs, right? So that's been the fear that's been mongered around. And I think this is really trying to address that head on, which is that, yes, OpenRAN, because of its programmability, is not only going to be able to handle and deliver the capacity using multi-use MIMO technologies, but is also potentially going to be better because you're introduce innovation from partners that could not do it before in the legacy system. So I think that's a pretty important milestone.
And we're moving into the more technology conversation, so we've kind of got there, which is great. But just to quickly backtrack, for those who are not that familiar, could Sachin, I guess, say with you, could you just in layman's terms, if you like, just summarize what the RIC is and what it's delivering, why it's important in terms of this openness and control?
Absolutely. So the RIC stands for the RAN Intelligent Controller. And a good analogy for those of who are familiar with the networking world is, think of it like an SDN controller, but for the radio access network. So we have the 5G or 4G radio access network. It has the underlying base station. So think of that as the data plane, right? The DU and the CU. So that's the thing that's actually handling all the bits. But there's some intelligence that was traditionally packaged inside the base station. And those intelligent algorithms were making decisions like, how should I use spectrum, right? So which flow should go on which piece of spectrum? How should I do load balancing? And all these usual things that you need to do to optimize the network. And what the RIC is trying to do is abstract that intelligence out with open interfaces and provide those APIs and programmability to applications to deliver that intelligence in a modular, decoupled manner. Now, this has some pretty important consequences because it basically means that a new startup or someone inventing something new on network optimization does not have to go build an entire base station. They can actually go build one app and deliver that innovation without having to deliver that entire base station product, which was historically the case, right? And that basically meant that very few startups succeeded in this space. So that is one of the main intents for actually building the rig. And the other thing is it's actually allowing monetization opportunities, right? So traditionally, the network has been a bit pipe, and applications really sit on top and don't really have any interaction. But with this kind of program, the applications actually can program the network infrastructure for what kind of connectivity they need and deliver differentiated experiences. So I think both of those, innovation even in the radio optimization space, as well as so modernizing the network and monetization of the network with new services that truly differentiate themselves by programming the network for what they need.
So I mean, it wouldn't be overemphasizing them to say that the RIC really is the central point that's giving you that flexibility and openness that then allows the whole ecosystem to come in. So it's really giving you that flexibility to allow, as you say, to allow an innovator, a startup to come in and deliver their piece without having to deliver the entire system, which is perhaps what would have happened before.
Precisely. And I mean, I think that's going to unlock a lot more innovation. There's a lot of great work in academia and universities that has just not had its way to practice because it's been so hard to do so. So I think I'm really excited about what's coming in the next 2-3 years on this front.
I think, and just you mentioned the work we're doing with Vodafone and Cohere and others. Lorcan, would you be able to summarise the sort of the key takeaways from that in terms of the material benefits that have been demonstrated in working with them and the partners?
Yeah, a couple. I mean, from a kind of a radio perspective view, right? The kind of outlier ends up looking a bit like you can probably double effective performance at the lower bands and maybe get so this kind of lower band spectrum, 700 megahertz, you could probably by more effectively deciding where people are moving to, you can place capacity more effectively. Quite very innovative use of the scheduler resources. And then at the higher bands, Sachin referred to the 3.5 gig and the kind of mid-band spectrum, maybe 4 or 5 times performance improvement. And then building on that, we see already a whole lot of people looking at energy saving applications, power down different parts of the network, more efficient placement of capacity in a cluster rather than just a node based comparison. Yeah. And the other real benefit, actually, I mean, what I saw going through all of that was just a really collaborative way of working. So you're really taking modern application processes, agile development processes, people working together in a team to meet a common objective. And every week making serious improvements in how the algorithm was working, how the system was delivering performance. And that's maybe something people have forgotten how to do, right? So they're remembering how to do that. Like a lot of us built these things a long time ago. But it was really an eye-opener for me to see people working well together. So phenomenal teamwork, actually, really quite.
So that's good. So we're starting to see that ecosystem playing.
Yeah, really working. Yeah,
and getting some real results. It's fantastic. Yeah. So we're running up against time. I'll come back to Sachin for one last thing. Looking forward, what's the next big milestone you're looking forward to in this space?
Well, the proof is always in the pudding, right? Or in this case, in the deployments. So I think there are some pretty big commercial deployments that are now going to go live that I think are really going to move the needle in proving that this is the way to go in the future. So Dish, which VMware has been providing the cloud for the RAN, will be going live with the first ORAN compliant 5G network, fully cloud native, going deployed later this year. And so that's a pretty large scale network in the US that will embrace this entire architecture. So that's a big milestone. Verizon also has been public about them rolling out 5G on an OpenRAN virtualized RAN architecture, and that is also going to be an important milestone. And I picked these two not because they're the only two. There's a lot more, but Dish represents a greenfield large-scale deployment, and Verizon represents a brownfield large-scale deployment. Verizon has legacy vendors and legacy infrastructure, and they're still going with this. So I think it shows that on both of these kinds of customer deployments, greenfield as well as brownfield, OpenRAN is already here now.
Excellent. So plenty to look forward to in not that distant a future as well. So that I think both of those happening within, we're talking months or weeks or months, aren't we? I think for this, so not far away. Excellent. Look, thank you both. We probably went a little bit longer than we normally do on these sessions, but it's a fascinating conversation. So thank you very much for your time. If folks are watching this on demand, don't forget you can reach out through LinkedIn, and if you've got any questions, we'll try and follow up through LinkedIn. So, but for now, thank you very much, and thank you again, gentlemen.
Thanks, Nigel.
Thank you.